Hi guys, welcome back to General Chemistry course. So for today's video, I'm going to discuss the periodic table of elements. So I'm hoping that everyone has their own periodic table of elements and scientific calculator before proceeding to the next slide. So after this video, the students are expected to determine the symbols of an element, name the parts of an element square, then relate the arrangement of the periodic table, and last, distinguish metals, nonmetals, and metalloids of an element. So I'm frequently saying element. So what is element first? An element is a type of pure substance that cannot be broken down into simplest form. So the elements, alone or in combination, make up our bodies, our world, our sun, and in fact, the entire universe. So scientists have identified 19 naturally occurring elements and created about 28 others. So in total, there are 118 elements in periodic table. So the air, water, fire, and earth are made of elements. So this is the elements composition of Earth's gas. And the most abundant element in the Earth's gas is the oxygen, followed by silicon. But when we talk about the element composition of the Earth as a whole, including the core, the mantle, and the crust, the most abundant element is the iron. Because remember, the core of the planet Earth is mostly made up of iron. The element composition of each planet or celestial body makes them different from each other. According to NASA, the Mars is made up of thick layer of oxidized iron, dust, and rocks, making them a red planet. Then second is the 55 Cancri. This is an exoplanet. It is mostly made up of carbon, making its surface diamond. Then last is the Sun. Sun is the star of our solar system. It is made of 91% hydrogen and 8.9% helium, making it a ball of fire. Celestial bodies have different element composition, but as human, we have same element composition. We are made of oxygen, 65%, 18% of carbon, 9.5% of hydrogen, 3.2% nitrogen, 1.5% calcium, and 1.2% phosphorus. We also have trace elements in our body, such as potassium, sulfur, sodium, chlorine, magnesium, and others. A change in the element composition of a person can cause illnesses or worse, death. Now, let's proceed to periodic table of elements, or just periodic table. The periodic table is a tabular display of chemical elements which are arranged by atomic number, electron configuration, and recurring chemical properties. All elements that can be found in the Earth are listed in periodic table. So who was the creator of the first accepted version of the periodic table? So he is Dmitry Mendeleev. Dmitry Mendeleev grouped elements according to their atomic mass, and as he did, he found that the families had similar chemical properties. He also left blank spaces to add the new elements he predicted would occur. So what is a square or element box? So different periodic table can include various bits of information, but usually it has atomic number, symbol, atomic mass, and number of valence electron. So elements are organized on the table according to their atomic number, usually found near the top of the square. So this is the atomic number. So atomic atomic number is the number of protons found in nucleus of an atom. So it means that the atomic number indicates the number of protons in the atom. So for instance, carbon has 6 protons, so its atomic number is 6. The atomic number is unique to that element. No two elements have the same atomic number. So next is atomic mass. Atomic mass refers to the weight of an atom. So here it is. Then, this is a combination of protons and neutrons. So the unit of measurement for an atom is called AMU, or the atomic mass unit. 1 AMU is equal to the mass of 1 proton. So there are 6 times 10 raised to 23 atomic mass units in 1 gram. So look at the scales here. The combination of 6 times 10 raised to 23 atomic mass units is equal only to 1 gram. Remember that the electrons are 2,000 times smaller than 1 atomic mass unit. So now let's proceed to the third part of the square, and that is symbol. Symbol is an abbreviation of the element name. All elements have their own unique symbol. It can consist of a single capital letter or a capital letter and 1 or 2 lowercase letters. Example, the letter C is the symbol for carbon, and the symbol for noble gas xenon is the Xe. So these are the common elements and symbols. So most symbols of the elements are the first letter or first and second letter of an element's name. But there are several elements that their symbol are not related to its name, like iron, gold, silver, lead, mercury, etc. Don't be surprised because their symbols are the first and second letter of their Latin name. So here it is. So for antimony, the symbol of antimony is the SB because it comes from the word or the Latin word stibium. Then copper, Cu, for cuprum, gold, Au, aurum, and so on and so forth. So this is the element name, the Latin name, where their symbol came from. Last, for the basic parts of the square is the valence electrons. The number of valence electrons an atom has may also appear in a square. Valence electrons are the electrons in the outer energy level of an atom. These are the electrons that are transferred or shared when atoms band together to form a compound or a substance. Then let's proceed to classification of elements. The elements of the periodic table can be divided into 3 main categories: metal, non-metal, and metalloids. So the blue color here is the metals, the light green or the mint green is the non-metal, and the purple is the metalloids. So listed here are the properties of metals. Metals are good conductors of heat and electricity. Also, metals are ductile. It can be stretched into thin wires, and malleable. It can be pounded into thin sheets. Next is the properties of nonmetals. Nonmetals are poor conductors of heat and electricity. Nonmetals are not ductile or malleable. Solid nonmetals are brittle and break easily. Many nonmetals are gases. Next is metalloids. Metalloids have properties of both metals and nonmetals. They conduct heat and electricity better than nonmetals, but not as well as metals. They are ductile and malleable. Elements in the periodic table are also grouped into families, which are the columns. Elements in families have similar properties. Then for horizontal rows, it is called as period. Elements in periods do not have similar properties. Listed here are the properties of families and periods. So the columns in the periodic table are called families. Elements in each family have similar but not identical properties. For example, lithium, sodium, potassium, and other members of the family 1A are also white, shiny metals. All elements in a family have the same number of valence electrons, while for the period, the horizontal row of the periodic table of elements, the elements in a period are not alike in properties. In fact, the properties change greatly across even given row. The first element in a period is always an extremely active solid. The last element in a period is always an inactive gas. So let me discuss to you the families one by one. Okay, hydrogen. Hydrogen is a unique substance or unique element in the periodic table of elements. So the square of hydrogen is found on the top of the family A1, but it is not a member of that family because hydrogen is in a class of its own. So this is the square of the hydrogen. It is a gas at room temperature, so hydrogen can be classified as noble gas. It has one proton and one electron in its one and only energy level. Hydrogen only needs two electrons to fill up its valence shell. Okay, then let's proceed to alkali metals. Alkali metals is found in the first column of the periodic table. Atoms of the alkali metals have a single electron in their outermost level. In other words, one valence electron. So they are shiny, have the consistency of clay, and are easily cut with a knife. So alkali metals are the most reactive metals. They react violently with water. Alkali metals are never found as free elements in nature. They are always bonded with another element. So what does it mean to be reactive? We will be describing elements according to their reactivity. Elements that are reactive bond easily with other elements to make compounds. Some elements are only found in nature, bonded with elements. What makes an element reactive? An incomplete valence electron level. All atoms, except a hydrogen, want to have 8 electrons in their outermost energy level. This is called the octet rule. Atoms bond until this level is complete. Atoms with few valence electrons lose them during bonding. Atoms with 6, 7, or 8 valence electrons gain electrons during bonding. So for example, we have sodium and chloride. Sodium is a member of A1 family or the alkali family. And it says that some elements or some member of the alkali family only found in nature bonded with other elements. So sodium can be found in nature with a combination of chlorine. Then sodium has 1 valence electron, then chlorine has 7 valence electrons. So in order to meet the octet rule, or the so-called octet rule, the sodium must lose the 1 valence electron in its outer energy level to donate to chlorine, and chlorine receive the 1 valence electrons to meet the 8th energy level. So this is the process. Sodium loses 1 electrons, chlorines gain 1 electron. So sodium becomes positive atom, and then chlorine becomes negative. So remember that there are two types of bonds. The metal plus non-metal, what happened to sodium chloride is ionic bond. Then metal plus polyatomic ion, ionic bond. Non-metal plus non-metal is covalent bond. And hydrogen plus non-metal is covalent bond. Second is the alkaline earth metals. They are never found uncombined in nature. They have 2 valence electrons. Alkaline earth metals include magnesium and calcium, among others. Next is the transition metals. Transition elements include those elements in the B families. These are the metals you are probably most familiar. These are copper, tin, zinc, iron, nickel, gold, and silver. They are good conductors of heat and electricity. The compounds of transition metals are usually brightly colored and are often used to color paints. Transition elements have 1 or 2 valence electrons, which they lose when they form bonds with other atoms. Some transition elements can lose electrons in their next to outermost level. Transition elements have properties similar to one another and to other metals, but their properties do not fit in with those of any other family. Many transition metals combine chemically with oxygen to form compounds called oxides. Next is the boron family. The boron family is named after the first element in the family, the boron. Atoms in this family have 3 valence electrons. This family includes a metalloid boron, and the rest are metals. The family includes the most abundant metal in the Earth's crust, the aluminum. Next is carbon family. Atoms of this family have 4 valence electrons. This family includes a non-metal carbon, metalloids, and metal. The element carbon is called the basis of life. There is an entire branch of chemistry devoted to carbon compounds called the organic chemistry. Next on the list is the nitrogen family. The nitrogen family is named after the element that makes up 78% of our atmosphere, the nitrogen. This family includes non-metals, metalloids, and metals. Atoms in this nitrogen family have 5 valence electrons. They tend to share electrons when they bond. Other elements in this family are phosphorus, arsenic, antimony, and bismuth. Then next is the oxygen family. Atoms of this family have 6 valence electrons. Most elements in this family share electrons when forming compounds. Oxygen is the most abundant element in the Earth's crust. It is extremely active and combines with almost all elements. Then we have halogen family. The elements in this family are fluorine, chlorine, bromine, iodine, and astatine. Halogens have 7 valence electrons, which explain why they are the most active nonmetals. They are never found free in nature. Halogen's atoms only need to go in electrons to fill their outermost energy level. They react with alkali metals to form soils. Second to the last is the noble gases, or I called it independent elements. Noble gases are colorless gases that are extremely unreactive. One important property of the noble gases is their inactivity. They are inactive because their outermost energy level is full. So that's the reason why I called it independent. Because they do not readily combine with other elements to form compounds. The noble gases are called inert. The family of noble gases includes helium, neon, argon, krypton, xenon, and radon. All the noble gases are found in small amounts in the Earth's atmosphere. The last family in the periodic table of elements are the rare earth elements. So the 28 rare earth elements are composed of the lanthanide and actinide series. One element of the lanthanide series and the most of the elements in the actinide series are called transuranium, which means synthetic or man-made. So before I end this video or this presentation, I want to show you all the nutritional elements in the periodic table. The dark green square, such as hydrogen, carbon, nitrogen, and oxygen, are the 4 basic organic elements which form the 4 macromolecules of life: the lipids, carbohydrates, protein, and nucleic acid. While the green one, the sodium, magnesium, calcium, potassium, phosphorus, sulfur, and chlorine are the quantity elements. The yellow-green, such as manganese, iron, cobalt, copper, zinc, selenium, iodine, and molybdenum, are the essential trace elements. So this chromium is deemed as essential trace elements by the United States, but not by the European Union. Then this one, or this color, suggested function from deprivation effects or active metabolic handling, but no clearly identified biochemical function in human. The orange one is limited circumstantial evidence for trace benefits or biological action in mammals. Then the rest is no evidence for biological action in mammals, but essential in some lower organisms. So this is the end of our discussion. Thank you for watching and listening. I hope you just learned something today. So again, thank you and God bless us all.